Glad to be here at CD Summit. That's actually my first, so I was one of the ones raising hands there on the first one. Really excited to be here. And today I'd like to share with you how we gained observability into our CI/CD pipeline. And let's start with a day in the life of a developer on duty, DoD. And the way it used to work for us, every morning the DoD starts the day going into Jenkins, the graduate project, first graduate of the CD Foundation, and checking the pipeline runs from the recent time, checking if anything is red, especially if there's a red master. And sometimes, let's admit it, people forget to go in and check. I'm sure it happened to you as well. And if there is a failure, then we need to go into the runs one by one and understand which failed, where it failed, how many failed, why it failed. And when I say go into the different runs, we have the back-end pipeline, we have the front end, we have smoke tests, different pipelines that go, and you need to start comparing to understand the patterns across the runs, across branches, and so on. Also, without any easy way to compare with historical pipeline runs. So I see some nods here, so I guess I'm not the only one who experienced that. And just to give you a few examples of questions that it took us too much time to answer. Did all runs fail on the same step? Did all runs fail for the same reason? Did the failures occur on a specific branch, maybe on a specific machine? If something takes longer, is that okay? What's the benchmark? These are the sorts of questions that it took us too much time to answer, and we realized we need to improve. I'm Dotan Horovits. I'm the principal developer advocate at logs.io. At logs.io, we provide a cloud-native observability platform that's based on popular open source tools, Prometheus, OpenSearch, Jaeger, and so on. I myself, I'm an advocate of open source and communities in general, and the CNCF in particular, hopefully to be more active on the CDF later on, and obviously very exciting to be here on stage as part of KubeCon. I am co-organizer of the local CNCF chapter in Tel Aviv, where I'm based. You're all welcome to our meetups, and I also have a podcast, Open Observability Talks, if you're interested in the topic. And before I go into how we improved our CI/CD with the problems we talked about, let's first understand what we need to improve on. And essentially, there are 4 key metrics for DevOps performance. They're known as the DORA metrics. And very briefly, it's the deployment frequency, the lead time for changes or cycle time, there's the change failure rate, and the mean time to recovery, the MTTR. They cover the full spectrum of pre-production and post-production activities. If you want to learn more, I did join an introductory article here at the bottom. You have the QR code. I don't have the time here, but very fascinating topic. And in our case, the metric we wanted to improve on was the lead time for changes. The amount of time it takes to a commit to get into production, which in our case was too high and was holding us back. And as I mentioned, we're expert at observability. That's what we do for a living. So for us, it was very plain and obvious that what we're lacking here, in our case, is observability. And Jenkins did provide some observability. You could go into the pipeline run, as you all know. You can see for each step how much time it took. So you could see that granularity. And we also wired it to Slack so we can get alerts when something fails and so on. But that wasn't enough for us. We wanted to find a way to monitor aggregated and filtered view across different pipeline runs, across different branches, across machines, to be able to see the full picture on a scaled time frame with our own filtering demands. So we set out on this project in the engineering with these 4 requirements. First, we wanted dashboarding and aggregated views to see exactly what I was talking about, across pipeline runs, across branches, across machines, and so on. We also wanted historical data to be able to understand the trends and to identify patterns. Then we wanted reports and alerts to automate as much as possible. And lastly, we wanted to be able to view flaky tests and test performance to understand the impact on the overall performance of the pipeline. So these are the 4 requirements. And now that we understand what we want to achieve, let's talk about how to achieve it. And essentially, it takes 4 steps: collect, store, visualize, and report. In terms of the tech stack, we have a lot of expertise with the Elk stack, Elasticsearch, and Grafana, and now also with OpenSearch. So for us, that was the natural point to start. So I'll start with that and show you how we went through these 4 steps. And let's start with the collect phase. What we did is we instrumented the pipeline to collect all of the relevant information and put it into environment variables. What kinds of information? You can see here the branch, the commit-cha, the machine IP, the run type, whether it's scheduled or triggered because of merge to master or for push to branch or whatever, the build number, anything essentially that you can get out of your pipeline, grab it. That's the collect phase. And then after collect comes store. For that, we created a new summary step at the end of the pipeline, where we ran a command to collect all of the pipeline information from the environment variables and create a JSON with all of this information and stored it in Elasticsearch. We have our own, so it was a natural for us, and now we move to OpenSearch. So that's on the store phase. And it is important, I know that there are people here from Jenkins, so you'd probably ask, but Jenkins has some built-in persistence capabilities, and we did try them. But there were some downsides. Jenkins keeps all the builds and stores them on the Jenkins servers, on the Jenkins machines, which could burden these machines. And the best practice is to, then you need to start deleting, you need to limit how many builds to keep, how many days to keep, and it limits your historical data. And that wasn't enough for us. We needed a more powerful access to our historical data. We wanted to persist historical data in our control, to control the duration, to control the retention, and very importantly, to do that off of the Jenkins server so as not to load the critical path. So that's on the store phase, and after store comes visualize. And now that all the pipeline run data is in Elasticsearch, it's very easy to build Grafana dashboards and visualizations. If you work with OpenSearch, then with OpenSearch dashboards. And I want to recap on the questions that I mentioned before that were hard, difficult to answer. Things such as, did all runs fail on the same step? Did all runs fail for the same reason? How many, if they failed on a specific branch or on a specific machines? These questions dictated the types of visualizations that we needed to create. So I want to give a few examples of visualizations to answer these sorts of questions, just for you to tease sorts of similar visualizations that you may want to explore in your case. And let's start with the top-line view, understanding how stable the pipeline is. For that, there's the success and failure rates overall in a table or on a specific time range on a graph. Very easy to just see in one bird's-eye view if we're good or not. You want to find problematic steps, then you have the failures segmented by pipeline steps. Again, very easy to see the spiking step there. If you want to detect problematic build machines, then failures segmented by machine. And by the way, that was very, very useful. It saved us wasting time looking for issues in the released code. Rather, when we see such a machine, we just go, we kill the machine, we let the auto-scaling spin up a new one, and then you start clean. And oftentimes that solves the problem. So environmental issues with the CI/CD is a problem, and I'll get to that, back to that also later. And the duration per step. As I mentioned, Jenkins does allow you to see per step in a specific run, but we wanted to see aggregated view across pipelines, across branches, across machines, and use to scale and to filter. That answered this requirement. And after visualize comes report and alert. As you recall, before the DoD, the developer on duty, needed to go in and manually check Jenkins for the last runs. Now you get beginning of day, start of day report to your Slack, something like you can see here on the screenshot, with a link obviously to the full dashboard and with the snippet of the dashboard inside the notification itself. So oftentimes it's fairly easy to see already from the snapshot if you're good to go and you can finish your morning coffee, or if you need to go quickly click the link and start investigating. And we can also, of course, create alerts on top of that. You can compose any composite alert based on the data that we collected in the collect phase. So you can ask things such as if a number of failures, sum of failures goes above X, or the average duration goes above Y, trigger an alert. Essentially anything that you can formalize as a Lucene query, you can automate as an alert. By the way, this is done based on an alerting mechanism we built on top of the Elk Stack and OpenSearch, and it's not only limited to Slack. We use Slack, but you can use other endpoints. As you can see here, PagerDuty, OpsGenie, MS Teams, and others. In our case, the preferred method is Slack. That's what we use in the organization. So that's about Jenkins. But as we know, CI/CD is not just Jenkins. And what else? If you recall the requirements, we also wanted to analyze flaky tests and test performance. So following the same process that I mentioned, we collected the relevant information from our test run, stored the data in Elasticsearch, and then created Grafana dashboards. As you can see here, you can see failure count, failure rate, moving averages, failed tests by branch over time, and so on. So really powerful. And as before, in addition to visualize, we can also create reports and alerts. So following the same flow. One important point to mention is the flexibility. Once you have the data in Elasticsearch or in OpenSearch, the team has the flexibility to choose which visualization serves the needs. So different teams created different visualizations over the same data to suit their needs and style. This, for example, is the other extreme. They didn't like graphs. They wanted everything in table view, just the same. So that's the full process. And let's summarize. We instrumented Jenkins pipeline to collect all the run data that we could and put it in environment variables. Then we, at the end of the pipeline, we created a JSON with all that data and persisted it to Elasticsearch or OpenSearch. Then we created Grafana visualizations on top of the data. And lastly, created reports and alerts on the data. Collect, store, visualize, and report. So that's the beginning of our journey. But then what's next? What if you want to investigate the performance of a specific pipeline's run? That was the following question. And actually, distributed tracing is perfect for that. And in fact, Jenkins can emit traces, just as it can emit logs. So we decided to visualize jobs and pipeline executions on distributed tracing. How many know distributed tracing with a raise of hands? Okay, we have around half of the people knowing. So very briefly on distributed tracing, it helps pinpoint where failures occur and what causes poor performance in production systems. So it's not specifically for CI/CD. So if you think about a microservice architecture with a request flowing through a chain of interacting microservices, if you want to ask a question such as where did the failure occur through this chain, or where did the performance degradation come from, where's the critical path? This is the sorts of questions that distributed tracing is perfect for. And the way it works is that each call in that chain, or in our case, each step in the pipeline run, emits a span, which is a sort of a structured log with the trace ID, with start time, with the duration, and some other context. And then there's a backend that collects all these spans, chain them back based on causality, and visualizes them. That's very much in a nutshell what distributed tracing is. And now that we understand distributed tracing, let's see how to add it to our CI/CD pipeline. Following the same flow: collect, store, visualize, and report. And let's start with the collect phase. For the collect phase, we decided to use OpenTelemetry collector. For those who don't know OpenTelemetry, it's an open source that provides unified collection of logs, metrics, and traces, unified standard way. It's a CNCF project. I actually delivered the talk about OpenTelemetry at KubeCon Europe back in May. And at the time, OpenTelemetry was already GA, generally available for distributed tracing, so we chose it. And the way to do that is very simple. You install the OpenTelemetry collector. You need to then install the Jenkins OpenTelemetry plugin, and then configure the plugin to send the span data, the trace data, to the OpenTelemetry collector endpoint in OTLP over gRPC protocol. So pretty simple. That's the collect phase. And after collect comes store. And for backend, we used Jenkins, Jaeger, which is a very popular open source tool for distributed tracing. It's also a CNCF project. And we use Jenkins to monitor our production environment. So we did the same here. We also have our own managed Jaeger, so we use that. But it works just the same if you have your own. Actually, if you run it, I wrote a guide on how to install Jaeger on Kubernetes in production. You have a link here if you find it useful. And what you need to do in this phase is to essentially configure the OpenTelemetry collector's exporter to send it to the Jaeger backend. And that's about it. And once you have that, after store comes visualize. The visualize step here is very simple because Jaeger UI has built-in visualizations. You don't need to start composing dashboards. The most popular view is the timeline view. As you can see here, on the left-hand side, you see the indented tree structure, and then on the right-hand side, the Gantt chart. And it's very easy to see the pipeline sequence. You can see where's the critical path. You can see how much time each step took, which steps ran in parallel and which sequentially. And if you have a pipeline that the runtime is too long and you need to optimize, it's very easy to see where most of the time is spent and where to optimize. So that's and there are other visualizations, by the way. There's the sort of dependency graph view. There's the trace statistics. There's even a flame graph that was added very recently. So lots of different visualizations. And that was for Jenkins, but as we said, CI/CD is more than Jenkins. And what can we have beyond just the Jenkins visualization? You can later add instrumentation for Maven, for Ansible, for other tools to gain finer granularity into your traces and into your steps. For example, here, everything that you can see in yellow is Maven. So that what before was one big chunk, one big span, now black box. Now you can open it and see the breakdown into the individual build steps in Maven and individual details and length of each one. So very, very useful. So we've seen how to add tracing into our CI/CD pipeline with the same steps: collect, store, visualize, and of course you can also create alerts and reports. Just like any other, it's like Elasticsearch, like OpenSearch, very easy. And what's next? So if you recall, I mentioned that many of the pipeline runs actually failed because of problems in the environment rather than a problem with the deployed code. So we decided to add and monitor metrics from the Jenkins servers and the environment, the system, the containers, the JVM, essentially anything that could fail irrespective of the released code, and monitor that. So following the same flow, starting with the collect phase. For the collect, we use Telegraph for our production environment. We also use that here. It's an open source by Influx Data. And one of Telegraph's strong suits is the rich suite of plugins that it has. So you have a general link here for the plugins directory. I'll mention a few plugins here. And what you need to do is 2 steps. First, you need to configure Jenkins to expose metrics in Prometheus format. We use Prometheus extensively in our production environment. We also use that for the CI/CD monitoring. And that's a very simple configuration in the Jenkins web UI. And then you need to install Telegraph if you don't already have one, and configure Telegraph to scrape the metrics off of the Jenkins servers with a Prometheus input plugin. Okay? Prometheus input plugin, that's what you'd be looking for. That's first phase. Second phase, as we said, after collect, it's store. And as I mentioned, Prometheus is our choice for production environment, also the choice for CI/CD monitoring. We actually have our own Prometheus as a service, so we use this one. But the same would work for any Prometheus or Prometheus-compatible backend store. And what you need to do is to configure Telegraph to send the metrics to Prometheus, and you have 2 options for that. You can do it in pull mode or in push mode. Pull mode is the default for Prometheus, in which case you configure Telegraph to expose a /metrics endpoint that Prometheus can scrape. If you want to do that, you use the Prometheus client output plugin. And if you want to use the push mode, you use the HTTP output plugin with the data format Prometheus remote write. So very simple, that's the store phase. And after store, once we have all the data in Prometheus, it's very easy to create Grafana visualizations on top of that data, on top of the time series data. And you can see example of the dashboard here. Obviously, you can filter, as you can see at the top. Here, you can filter by the build type, by the branch, by the machine ID, by the build ID, and other filters, so very easy. And this is the example of the system type of monitoring, CPU, memory, disk usage, and so on. You also can monitor the Docker container metrics. As you can see how many running, stopped, paused container by Jenkins machine, the container CPU, memory, I/O, network, and so on. So, and all of that, of course, can filter to investigate a specific machine, a specific branch, or a build type, or and so on. You can also monitor the JVM metrics on the Jenkins machines, like the thread count, the heap usage, the garbage collection duration, and so on. And you can also monitor the Jenkins nodes, the Jenkins queues, the jobs executors themselves. So here are some examples that you can see. I'm not sure if you can see here the Jenkins job count over time, breakdown by job status, how many aborted, how many failure, not built, and so on. So lots of information here. And actually, that was so useful that our users asked that for that dashboard. So we made that available as a pre-built dashboard that they can install in one click, because it was very useful. And of course, you can set alerts on that time series data on the metrics. So let's summarize what we've seen. Treat your CI/CD like you treat your production environment. Just like you use Elasticsearch, OpenSearch, Prometheus, Jaeger to gain observability into your production environment, do the same with your CI/CD environment and pipelines. And actually leverage also the same stack so that not to reinvent the wheel. As I mentioned, we set out on this project to achieve 4 goals. We wanted dashboards and aggregated views to be able to see from several pipelines belonging to different runs, different branches, on our own range, time range, filters, and so on. Secondly, we wanted historical data and controlled persistence to do that off of the Jenkins machines to determine the duration, the retention of the data. We wanted reports and alerts to automate as much as possible. And we wanted to be able to see flaky tests and test performance in general. These were the goals that we've achieved. And we did that with 4 steps: collect, store, visualize, and report. Collect being is instrumenting your pipeline to get the events, the state, metrics, traces, and so on. Store and visualize according to the type of data. So Elasticsearch and OpenSearch for the logs and events, Prometheus and Grafana for metrics, Jaeger for traces, and so on. And then alert and report to automate as much as possible. And last point, what we gained, a significant improvement in our lead time for changes, dramatically shortened. We also, on the way, improved the developer on duty shifts, much less of a nightmare these days. And lastly, based on the same open source stack that we know and love. So that's what we gained. If you want to read more about that, I wrote a long-form guide to CI/CD observability. You have the link and the QR code here if you want. And if you have any comments on the talk or on the guide, feel free to reach out to me on Twitter at Horovits, or I'll be here at the Logs.io booth if you want to grab me in person, or I'll be on the virtual booth later today on a Q&A. I don't know if you have time now for a Q&A, so up to you. We don't have, so you can grab me later then. Thank you very much for listening. I'm Dotan Horovits. Thank you very much.